slash test before doing a complete hookup to make sure everything works the way it's supposed to work, and the way I'm gonna have it set up to work as normal, how it should. And including that, I'm also gonna use my backup setup to show you also in this video of how it works in a time of no wind or very low clouds or no clouds at all, for people who might be in a hurricane area of the country, and or especially at night if your batteries are running low and you have another 6-7 hours of night and you need the power if you're in an off-grid setup and you don't have a windmill. So this is what I was talking about the backup setup, and I'm going to be using my generator, 6.5 horsepower. It's 3,500 watts. It's a little over and what needs to be to charge the battery, because in the manual for the Sky Blue it says nothing over 2,500 watts. But I'm going to show you how you still can use a decent sized generator, maybe 4,000, 5,000. So to charge the batteries. The only time you really limit the generator if you don't have a charge BMS. If you don't have a BMS, then you're really gonna need exactly a 2,500 watt or 2,000 watt generator, because that's the max input for a 48 volt system at 50 to 60 amp. This is a 50 amp, a My Sky Blue, but it can handle up to 60 amps. And when I had it connected directly, it was pulling about that's my battery voltage right now, but it was pulling about 2,500 watts, 2,700 watts from the generator, and the generator was dying out, or the breaker was tripping, because it has a trip breaker on there. Can't remember how much amps it is, but it tripped after 2,800 watts. So it actually pulled more than the 50 amps that it normally would have pulled to charge the battery bank directly. They had to connect it directly to the negative and directly to the positive without the BMS. So the generator will trip or generator will shut off under that heavy load. So what I did was, my BMS arrived. I got 3 of them because I'm gonna have 3 full banks, as you can see in my messy garage. But there's my other set of batteries there. There's another set over there. There's another it's not a full bank that just arrived outside, still on a pallet. And there's another half a bank still on a pallet inside the leaf casing that I didn't take a disassemble yet. So besides that, let me walk you through the connection. So remember I said to get a rectifier, eBay, preferably get something like this, 100 amps. You could buy a heatsink off eBay too, a decent size one. You're gonna use an appliance cord. The correction on the cord, this cord is only rated for maybe 1,000 watts or so, because it's like a 20 gauge wire, or 18 gauge wire actually. So when the generator is running, I have it plugged directly into the generator. It gets pretty warm from the power draw. So if you have a small 1,000 watt, then yes, you can grab it from appliance. But if not, it's good to go Home Depot and buy one of those heavier duty extension cord, or buy one of the wires that goes in the house that you run in the wall, and buy the plug end to put on the end of it and connect it to that could handle up to 30 amps or so, 30-40 amps to handle the load, because it's gonna get hot and you don't want it to get hot and melt inside and then the wires touch. You're gonna shut off the generator and burn it up. So it goes from the generator into the rectifier, and into the rectifier, as you can see, it follows. It goes into PV, positive and negative. Remember, it has to be polarity corrected, positive and negative. Pink is positive, the black is negative. And then on the right hand side, you have the green and the red. The red is the positive out, and the negative is the negative out to the battery bank. So my positive is going down, it's going around all the way to the back into the breaker, into the fuse breakers. Yes, these are fuse breakers. Whatever that came out of the UPS that I had, and I'm using it now as part of protection for my solar setup. So it goes up there, down. I'm using two sides as positive. So two of them are running a positive and going to one of the breakers set up, and out from the breaker it's coming down and to the battery bank. And then the green is coming down where I had it connected directly to the battery. Where you see the blue connector is, that was the direct hookup before the BMS, which it draw a lot of power to charge the battery bank, which this has the settings for LiPo batteries, acid batteries, and nickel batteries, and all different stuff in there. It has everything. This is one of the Make Sky Blue Wi-Fi smart smart charge controllers. So it does everything from inside Wi-Fi, using the Wi-Fi connection with your cell phone. So because of the drawing 40 amps, like I said, it pulled too much power from the generator and caused the generator to die out. So I connected the BMS to it to also balance and charge at the same time. And in the BMS, this is a smart BMS, the one that the Wi-Fi, the one with the Bluetooth, that you can go in the settings. I'm gonna put a picture up later. And in the settings, you can limit the charge current. That's the sweetest part about having this BMS. The system is parallel. It's a parallel system. It's not series. It's 8 batteries in parallel. 8P7S. Everything's in parallel. So in the BMS, it has a charge limit function. So it was set at 45 amp because it's a 320 amp BMS, but usually they want you to charge it at 50 amps. And I figure why, due to the heat sink, which is the actual plate with the labels on in the bottom, if you can see all the MOSFETs inside. So with that being so limited with cooling, they want to max it at 50 amps so it wouldn't burn it up. But if you put a heat sink on this, a decent sized heat sink on both sides of this, you can push it all the way up to where it needs to go with the adequate wire attached to it, for sure. But that's the reason why it's so limited, because the cooling of it. But if you could get it to stay cool within the parameters of it, it will do what it says it does. So in the settings, it has a charge limit function. I limit it to 30 amps. So it only charges up to 30 amps. So now when I started the generator, which I might do in the next video and put the generator outside because it's gonna be so noisy you might not hear what I'm saying. So you can see so you can see it functioning. It charges up to 30 amps. So instead of the charge controller going all the way to 2800 watt, it maxed out at 1680, almost 1700 watts, somewhere around there. It maxed out at. The generator run kind of under load, but it still was charging. The voltage was still good because when it was at 2800 watts, it dropped this thing down to 90 volts. It was down to 90 volts from the current draw. So after I limited 30, it only dropped down to 118, 120, something like that. It dropped down to, which was perfect, and it ran for about 15 minutes perfectly fine. All because I set the limit to 30 amps. So now everything is working exactly how it should. The backup setup, if you do the setup, if it's cloudy or not, it's worked perfectly fine, like perfect. So this should be the settings that you set it up. Set at 30 amps if you're using the generator. The backup, if you're using the solar panels, you can leave it at 40 amps because you have the constant power coming in from the sun or whatever, so you can leave it at that. But if you're using the generator, or using generator only or whatever, with a BMS, set at 30 amp current draw, so everything can run smoothly. The generator is not going to be heavy on the load and want to shut off. This is not going to heat up as hot, and everything's going to work exactly how it should. And it's going to charge everything up at 30 amps. And just leave it running, because as I say, this generator can run about 6 hours on a tank. and that's under half load. I think it can run that. I can't remember how many gallons it is. It doesn't say how many gallons the tank is on the top, but I think it's a 5-gallon tank. If I'm not, oh no, that's definitely not a 5-gallon. Gotta be like a 4-gallon or so. Yeah. So to go through my setup, yeah, I'm putting the loam in the middle of all of them. I didn't finish yet. It's just a rough setup to show you what I did. The BMS, the blue, which is the battery negative, because it's kind of hard on YouTube to see people really explain this in detail. The battery negative goes on your negative part of the battery. The battery negative. C is your charge. Charge negative means it goes on the negative input from the charge controller or your charger or whatever you connect to it. That's the negative side. So the BMS connects to the negative side of the battery, not the positive side. The positive side is connect directly straight to the positive side of the battery bank, or whatever you're using, the battery setup you're using. Positive goes straight to the battery bank. Doesn't go anywhere else but straight. The negative side, if you go into a BMS, goes to the black wire or the negative C on a charge controller. The negative B goes to the negative post on your battery bank. And then you have the wire harness, let's see, and it has a black, one of the wires, if you can see, there's a black wire. That black wire also goes on the same side as the blue and tap into blue. That's your negative. That's a negative for the BMS. Because how the BMS works is the big wire is your charging wire. The negative, the small negative, and the small red positive goes on the last wire in the series setup, because that's what measures your total volt package. So if you're 48 volts, the BMS really don't know how much volts your pack is based on the negative connection, because it's just a negative connection. That's all it is, from negative to negative. It's just going through the charge controller. So the positive, or some wires blue, some charge controllers have two different color wires, but this one has a black and a red. It's the whole total bank voltage. Black on negative, red on positive on the end of the bank. So it gathers all of the batteries in series all at once to make one complete 48 volt bank. So when you connect those wires, the BMS automatically knows this is a 48 volt system, because that's what you have on there. If you have the red on, say, 1, 2, 3, 4 of them, 1, 2, 3, 4, 7, 14, 21. So if you're 4 of your, let's say 4, it's gonna take you over 28 volt setup, because you only connected in series from the beginning of the first pack to the fourth pack, which is gonna give you the 28 volts or 32 volts if you charge it to 8 volts, however your battery setup is. So the negative being on the negative and all the way to the end of your other positive is the total amount of voltage for your whole complete bank, which when you turn on the BMS, it's going to detect that it's a 48 volt setup. So there's a few videos online showing the whole setup. I'm sure if you want, you can put in the comments to go through the whole thing in detail of how to connect the batteries. I printed out the paper, it got wet, of my setup in the 14S. This is the setup for it. Your negative starts over here, positive, positive, just keep connected. And if you have it in this type setup, if you notice, there's a bar. So your positive, the first positive wire, it starts at your positive, and then the second, your positive for the middle post, and then the second one next to it, which is the positive. Then it goes to a negative, but you have to skip the negative. So that's the whole concept of it, that they're not telling, they don't say it in detail on the videos. Each of these wires connect to a positive side of the battery, not the negative side. So if you connect, if this is your positive, you connect this to the positive. You skip negative, even though it's connected to the positive, it doesn't matter. It's still a negative side. So you skip this and go over to the positive side. So this is the positive between these two connection. This is the positive. This is the positive again, because this is the positive between this and this. It's kind of confusing, but you get it. Just each wire that's coming from the BMS in between the black and the last red, they are all positive connections. So that's how you connect in your battery bank. Connecting them all to the positive. And then that's it. It's gonna start charging and we're gonna start the generator up. But I don't know how noisy it's gonna be. Might be a little noisy. There's gonna be too much to take this outside. So I'm gonna just start it up to let you see it in action. So yep, one. Yeah, sorry about that. I must have pressed something wrong. But there it goes. That goes it working. It's fine up into the BMS. There you have it. It's charging. And go through the settings to show you. That's the voltage, 11 amps. So, yep, 123 volts, 800 watts. So it's charging the batteries. Line is rugged. On the BMS. Typical Android. As you can see, there you go, it's charging. And you can hear the generator going under load. That's what I'm talking about, how when going on the load at 30 amps. Yeah, so there it goes on the load. It works. And there you have it. I'm getting a little too noisy to stop the noise you can hear me. So you saw it was charging. Charging perfectly fine. And there you have it. A complete charging system for off-grid using a backup setup if you want. That was imitating a solar array or wind generator. Proof in the pudding. Thank you for watching.